Hello and welcome to another video on Laplace transform. In this video, we are going to transform sine 80. We are going to transform sine 80, meaning when f of t is equals to sine 80. Alright, we've discussed the whole concept behind Laplace, right? We've discussed the whole concept behind Laplace. If this is your first video on Laplace transform, do well to check the first two videos we did, where we explain the concept on Laplace. What does it mean? We said when it comes to Laplace, Laplace is just all about you transforming a particular function, say f of t to f of x. Meaning from this our table, you'll be given a function f of t. These are the possible functions you'll be given, right? So transform this function to f of x. What does it mean? We are saying initially your variable in this case is what? F of t. But the variable now is what? F of x. That's what it means. Do well to check the previous video for better understanding. Alright, say you have f of t is equals to sine 80. Say you have f of t is equals to sine 80. The question says that find the Laplace transform of sine 80. How do you go about it? Don't forget, Laplace transform is defined by a semi-infinite integral. You know, given any question, you want to perform Laplace transform, we call this formula. This is the first thing first, meaning this is the formula that generalizes Laplace. Alright, let me say this. The purpose of doing all this is that in the future, meaning as the class proceed, you'll be given several functions. No need of you substituting those functions given into this general formula, since you already have what is relatable to the function. Meaning, just like the way we've seen, say you are given f of t is equals to exponential negative 3t. You know, you can compare this function to this function, meaning f of t is equals to exponential negative 80. From this table, if you are saying the Laplace transform of exponential negative 80 is this, meaning the Laplace transform of this, meaning f of x, it becomes what? 1 over x plus 3. Right? We've seen how this works. So that is the whole idea of Laplace. Alright, let's transform this guy. Meaning the Laplace transform of sine 80. The Laplace transform of sine 80. You know, I'm following this general formula. So I'm saying the Laplace transform of f of t. In this case, what's f of t? Sine 80. It becomes what? Laplace transform of sine 80 is equals to the integral from 0 to infinity. Next up, we are saying f of t. What's the f of t? Sine 80. Substitute. It becomes what? Sine 80 multiplying what? Exponential negative st dt. Alright, now from this integral, once I'm done with this integral, any answer I'll be getting becomes the Laplace transform of sine 80. Right? Meaning your first task here, or the next step, is to evaluate this integral. How do you go about this? Let's bring it back to integration. What techniques of integration am I going to use to evaluate this? I'm using by parts. You know, by parts. When we say by parts, meaning we are saying u and dv. In this case, let's say this is u, and in this case, let's say this is what? Dv. But the question here, or how it works for a question like this, though we are using by parts in some cases, when it comes to in some cases whereby you want to transform that particular function, you make use of by parts, you make use of integration by parts. But for this very question, for this particular question, you are not going to use by parts, right? Just because you're using by parts, it becomes complex. It will take a whole lot of time, right? So we want to save time, or how it works generally as far as Laplace transform is concerned. Now, from here, what we are doing, this will take us back to the second transform we did, which was the transformation, or you say the Laplace transform of exponential negative 80. So what we want to do, since we said we are not using by parts, we are going to find a possible way in which we can write sine 80 in terms of exponential, in terms of what? Exponential, right? Now, from here, sine 80, do we have any trig identity or any relationship between sine 80 and exponential? Right? Yeah, we do. Go back to complex number. You know, we did complex number during our 100 level days. When we did complex number, we said that we have complex number in the rectangular form and we also have complex number in the polar form. So what we'll be using here, we are using the idea of complex number, but the polar form. Now, we call from complex number, I know that exponential j theta is equals to cos theta plus j sin theta. So this is equation 1. Call this equation 1. Now, if this is your equation 1, what you are interested in is sin 80. You want to express sin 80 in terms of what? Exponential. Now, observe. In this case, you know, there's what we call equal complex number. By equal complex number, you are saying that if we have a plus jb is equals to 3 plus j4. Question says that what the value of a, what the value of b. In this case, a is equals to what? 3 and b is equals to what? 4. Right? So just to understand the concept behind equation 1, since I said I want to represent or I want to express sin theta, you know, I said I want to express sin 80 in terms of exponential. Right? In this case, initially, the variable in this case is what? 80. But now I'm having what? Sin theta. Meaning from 1, you can say that exponential j theta is equals to what? Sin theta. Say this is what? 2. From 1, which is from complex number, the polar form of complex number, you can have this. Saying sin theta is equals to exponential j theta. Exponential j theta. But in this case, I'm using sin 80. Meaning, if I'm going with equation 2, I have to write it as exponential j80 is equals to cos 80 plus j sin 80. Say this is our new equation 1. From this equation 1, we then have exponential j80 equals to sin 80. This becomes our new equation 2. So this is how it works. Or you can just use the idea of equal complex number, saying I'm having the real part here and I'm also having the real part. I'm having the imaginary part here and I'm also having the imaginary part. Because at the end, by the time we get our final answer, meaning the Laplace, which is f of x, is not actually the Laplace of sin 80, but the Laplace of this exponential j80. But we are going to see how it works. So note this. This is what we need to know first. Since we said we can't use by parts for this very integral function. Next up, substitute. Substitute this our new equation 2 into the Laplace transform of sin 80. It becomes what? I'm having the Laplace transform of sin 80 then becomes integral from 0 to infinity. Substitute your sin 80, meaning exponential j80 multiplying exponential negative st dt. All right. Now from here, let's integrate. You know, I said this earlier. I said this particular function, which is sin 80, it is taking us back to what we did previously, meaning the way we found the Laplace transform of exponential negative 80. So we are also doing similar stuff here. So the same way we did that, we are also doing the same thing here. All right. From here, we said we come from indices. We can have this. I believe you already know it. So I'll be omitting some steps. Though for our level, we are meant to know it. But for sake of simplicity, I would have done it. But in this case, I won't be doing it just because it's still the same thing we did in our previous class. So you can watch the video on how we transform exponential negative 80 to 1 over s plus a for better understanding. All right, moving on. I'm having integral from 0 to infinity exponential j80 minus st dt. Right? Then from here, it becomes integral from 0 to infinity exponential negative all into bracket x minus ja multiplying t dt. All right. what we did here, don't forget, I said it. I said, the definition of Laplace, we said S must converge. When we say converge, S must be bigger, it must be greater than A. In this case, you saying A comes first, you are wrong. When we say converge, meaning bigger, so S must be greater than what? A. So your X is coming before, your X is coming first. Though all of this, I've explained this when we did the transform of this guy. So do watch the video. Alright, now from here, integrate. Let's integrate. Let's stop. I'm to integrate. You integrating, you then have exponential negative all into bracket x minus ja all divided by negative all into bracket x minus ja. Introduce your limit from infinity to 0. From infinity to 0. Now, factor out your constant. Factor out your constant. In this case, what's your constant? Your constant is 1 all divided by negative all into bracket x minus ja. So it becomes what? 1 divided by x minus ja. Open your big bracket, you then have exponential negative all into bracket x minus jat, then your limit, of course. Alright, now let's substitute our limit. You know how limit works. This is definite integral. By definite integral, your upper limit comes first, then your lower limit follows. Alright, let's do that. What do we have? From here, I have 1 divided by x minus ja all into bracket exponential. Anyway, I see, I'm substituting these two limits in place of t, right? So I'm having the first one, exponential negative all into bracket x minus ja multiplying infinity, negative exponential negative all into bracket x minus ja multiplying 0. Right? Now from here, let's simplify this. Simplifying this, it becomes 1 all divided by negative x minus ja multiplying, this becomes what? Exponential always to the power of infinity minus exponential always to the power of 0. That is, I'm having 1 all divided by negative x minus ja multiplying, I need to raise by infinity, exponential raised to the power of infinity becomes what? 0. Minus exponential raised to the power of 0, what do I have? I have 1. Alright, this becomes what? 1 all divided by negative ja multiplying negative 1. Negative cancel out. You are having what? 1 all divided by x minus ja. Alright, this is my final answer. This is what I'm getting, right? Initially, I want to transform sine 80. Doing my possible manipulation, saying we come from complex number, I have exponential j80 is equals to sine 80. By the time I perform my integration, after substitution, I got this. Does it mean that this guy becomes the f of s of sine 80? No, it doesn't work that way. I said it. I said what we are going to get later on, meaning our end result, it is actually the transform of exponential j80. Exponential j80. All this idea, we are making use of all this idea under the basis of complex number. Up to this level, when we have something of this nature in complex number, what do? We multiply the numerator and the denominator by the conjugate, right? We multiply the numerator and the denominator by the conjugate, meaning rationalization. We are rationalizing. You can say rationalizing such. So meaning you are rationalizing. Or say rationalize. Alright, now from here, let's rationalize. Meaning I have 1 all divided by x minus ja multiplying the conjugate of the denominator by conjugate, meaning I'm having negative, conjugate becomes what? Plus. If it was positive, the conjugate becomes what? Negative. So by doing that, I have x plus ja all divided by x plus ja. Okay, let's simplify this. Let's solve this. I then have x plus ja all divided by this. Open up your bracket. X multiplied by x, you have what? X square. X multiplied by positive ja, what do you have? Positive jax, right? You are done with this. The next one, negative ja multiplied by x, what do you have? Negative jax. Then negative ja multiplying ja, meaning negative j square a square, right? By the time you open this bracket, you have this. From here, this cancel out. You are left with what? S square minus j square a square. Recall, from complex number, j square is equals to what? Negative 1. J square is equals to negative 1. Substituting j square here, it becomes negative all into bracket negative 1 multiplied by a square. Therefore, you have a square. Meaning, this denominator becomes what? Positive a square. This becomes what? Positive a square. So I've gotten this. Initially, when we started solving, my first answer, I got this, right? Then performing the conjugate, I got this. Does that mean that this becomes the transform, or I say this becomes the Laplace transform of sine 80? No, that's not the Laplace transform. Now, up to this level, what you are seeing here, it is the Laplace transform of sine 80, meaning when f of t is sine 80 and when f of t is cos 80. Meaning what you have here is the Laplace transform. It is the Laplace transform of sine 80 and cos 80, meaning this function, it is the Laplace transform. Now, let's see how it works. Alright, up to this level, what we just need to do is to recall what we started with. Let's recall what we started with. Initially, we said negative j theta is equals to cos theta plus j sine theta. Right? This is what we started with. This is the basis of our substitution, saying negative j theta becomes what? Sine theta. So we are going back to what we started with, meaning this very equation 1 that we started with. Alright, now up to this level, in this case, we are doing comparison. You are doing what? Comparison. Meaning that, let's say you have, okay, I made mention of this previously. I said we have what we call what? Equal complex number. By equal complex number, you are saying the real part of the left hand side is equal to the real part of the right hand side. The imaginary part of the left hand side is equal to the imaginary part of the right hand side. Now that's what we are doing here basically. From this function, let's bring out the numerator, meaning I'm having s plus ja. The numerator of what we got, let's bring it out, equating it to this, meaning I have what? Cos theta plus j sine theta. Now let's take it back to equal complex number. By equal complex number, we are saying that the real part in the left hand side is equal to the real part in the right hand side. The imaginary part in the left hand side is equal to the imaginary part in the right hand side. Now, by doing that, it becomes s is equal to cos theta, say equation 1, a is equal to sine theta, say equation 2. Now, go back to this given question. Say f of t is equal to sine 80, meaning find the Laplace transform of sine 80. Find the Laplace transform of sine 80. The Laplace transform of sine 80. You know, after integrating, after my integral process, I got this. Meaning from here, I'm having x plus ja over x square plus a square. It implies just because you are transforming, you are transforming sine 80. And from equation 1 and equation 2, we've seen that sine theta, okay, let's use 80. Since I'm working with 80, say you have 80, say this is 80. Let's say this is 80, right? I'm transforming sine 80, meaning up to this level, I've seen this would have been the transform of sine 80. But back to equation 1 and equation 2, we are saying that A is equals to sine 80, x equals to cos 80. That is, from here, this implies that the Laplace transform of sine 80 is equals to what? A over x squared plus a squared. A over x squared plus a squared. Now, with this idea, the Laplace transform of cos 80, that becomes what? That's correct. Meaning the Laplace transform of cos 80 becomes what? S over what? S square plus a square. S square over a square. S square over s, x over x square plus a square. Now, back to your table. Meaning, given the function f of t equals to sine 80, what's the Laplace transform? A over s square plus a square. Given the function f of t equals to cos 80, what's the Laplace transform? It becomes what? S over x square plus a square. Alright, I want you to know the difference between sine 80 and cos 80. Your sine 80, the numerator is taking the constant, right? You know, earlier, or what we are doing basically when it comes to transform is that I'm expressing the function of t to the function of x. Observe the numerator of your cos 80. We still have it as x, right? But the numerator of your sine 80, you are having it as what? A constant, meaning a. Let's take example to see what I'm saying. Let's say you have this example. Find the Laplace transform of sine 3t. Number 2, find the Laplace transform of cos 60. Then lastly, find the Laplace transform of cos 40. Now, first thing first, solution. To get the Laplace transform of sine 3t, cos 60 and cos 40, the idea is very simple. Can you see the reason why we need to know this standard table of Laplace? This is what we call the Laplace standard form, meaning the standard Laplace transform. Alright, solution. Let's solve this question. Solving this question, the Laplace transform of sine 3t becomes what? The Laplace transform of sine 3t, doing comparison with what we've done so far, you know, it's said back to our table. If this is sine 80, this becomes the Laplace transform. If this is cos 80, this becomes the Laplace transform. Now, let's answer this first one. When f of t is equals to sine 3t. In this case, identify what is your a. What is your a? Doing comparison, your a in this case is what? 3. Meaning you are interested in knowing your a, then input values, right? Meaning the Laplace transform of this first example becomes what? 3 all divided by x squared plus 9. 3 all divided by x squared plus 9. 3 all divided by x squared plus 9. That's it. Now, next up, we are having the Laplace transform of cos 60. Similarly, doing comparison, identify what is your a. Your a in this case is what? 6. The Laplace transform becomes what? X all divided by x squared plus 36. 6 squared, meaning 6 times 6, you have 36, right? The next one, the Laplace transform of cos 40. When you say the Laplace transform of cos 40, identify what is your a. Same idea. It becomes what? X over x squared plus 16. Now imagine you don't know this f of x. You don't know the transform for sine 80, and you don't know the transform for cos 80. Meaning you have to substitute whatever function given to you in this general integration formula which defines Laplace. But with the help of this table, you'll be able to solve any given question. So that's what Laplace transform is saying. That's what it's saying. So we need to know all these derivation. We need to know all these derivation. So next up, let's transform sin 80 cos 80 then t raised to the power of n. But before transforming, let me chip this in, or let me say this. Your sin 80 and your sin 80, they are similar, they are synonymous, meaning the Laplace transform, they are the same. Similarly, also the Laplace transform of cos 80 and cos 80, they are the same, they are synonymous. The difference is the numerator. In this case, the both numerators, they are what, taking positive. Both numerators, they are taking positive. But for the hyperbolic function, which is sine and cos, the numerators are taking what, negative. But let's see the derivation, then write it in our table. All of this is what we'll be using as far as Laplace transform is concerned. Alright, let's take the next example.